Hello everyone, in this exercise of the Solidworks, we will create a hex nut bolt and assembly with the thread feature, and later on we will create a small animation. Let's start. File, new, part, this one. I am selecting the plain background. This background is useful for the demarcation purpose, okay? And unit is the mmgs, millimeter gram second. I am taking front plane sketch, and first I am taking the hexagon polygon, 6 side number hex bolt. I will create hexagon. This one smart dimension, this dimension flat faces, across flat faces. This dimension I can take. I am taking 20 mm. This one, and select this side vertical. Sketch is fully defined. This one future extrude boss face 10 mm, but I am taking mid plane. Okay, this one. Select this face, sketch. I am taking circle, this one and this. Select this circle, shift, and this tangent relation. Okay, now future extrude cut. I am taking only 7 mm. 7 mm flip side, but flip side, and at a 45-degree. This is chamfer. This is a chamfer type. In this way, and hit right button, and then mirror. Select front plane, because front at the mid. Cut extrude front plane. This one, this one. This I have created. Select this face, sketch. I am drawing a 10 mm bolt, M10 mm bolt. So this circle, and this is 10 mm. I'm taking 10 mm. Okay, this one extrude, future extrude. This is blind. This dimension I am taking only 60 mm. I am taking only 60 mm. Okay, now chamfer I am taking 0.50. Angle distance first. Angle distance. This is 0.50 at a 45-degree. This. Okay, this is the isometric front view. Isometric. Okay. Sorry, this is isometric view. Now I am applying the material for this. Edit material. I am taking 1023 carbon steel. Apply, close. Okay. This I am taking the dimension 60 mm. Okay. Now I will create a threads on this for M10. Whole wizard, there is a thread feature. This thread feature is available in 2018 version and beyond that. Okay. This one. Select edge. This edge. Okay. This is optional. Optional start location. And up to selection I am taking blind. I am taking this as a 55 mm. 55 mm. Okay, this is I am taking 55 mm. And here is the I am taking metric die, or you can take it this 50 mm. You can take thread length 50 mm. I am taking 50 mm thread length, and this size of the thread is M10 into 1.5. 1.5 is the pitch. If you the size which you want to assign is not available in the chart, in this chart, then you can override the dimension from here. This one, you can assign the value. Okay. And thread, cut thread, metric die, cut thread, right hand thread, or bottom right hand thread. Right hand thread, 0 angle, no locate profile, no use, 50 mm length as I have selected, but I am giving the offset. Offset I am giving in order to get the proper threads in the beginning. I am giving the offset that is equal to the pitch, that is 1.50. Pitch is 1.50, but this is going beyond, but I am reversing the direction. This is reversing the direction, you see, and hit the right button. This is the thread, isometric, this one, and I am saving it. Save part, hex bolt, this one, hex bolt, and this is the part A. Okay, save, rebuild and save. This is, I am taking the length is a 50 mm thread length. Total is this. Total length is the boss extrude is the total length is the, this is 60 mm. Okay. Now I am taking another part, file, this is saving, file, new part, okay, background plain white and front plane sketch, same polygon, hexagon, this is same, this is 20 mm extrude, but this vertical sketch is fully defined. Extrude boss weight, mid plane, this one, and this is 10 mm. Okay, this face sketch, circle, this circle, shift, and this circle, tangent. Okay, and future extrude cut, flip side to cut, I am taking only 7 mm. Okay, but angle at 50 degree, 45 degrees. Okay, this way. Future plane, mirror, that is the front plane. This one, this is the this. Okay, this is the nut, hex nut. Select this face, select this face. For M10 into 1.5 internal threads, dia of the hole will be 8.5 standard. That is a standard. In order to create the M10 thread, internal thread, the dia of the hole will be equal to 8.5. Select this face, this one, select, and so I am selecting this dia 8.5. This is standard 8.5. You can see from the chart of the internal thread, for M10 threads, internal threads, dia should be 8.5. Okay, now the future extrude cut, through all, this one, through all, this one. Okay, Now give the chamfer, fillet, chamfer. This is 0.5, only 0.5. I am giving the chamfer. We are drying the hex bolt and nut first. This one and this one. This one. Apply the material, same material. You can apply 1023. Apply, close. Okay. You can apply the metal as per your requirement. Okay. Now I will draw the internal threads. Thread feature, in the whole wizard there is a thread. Okay. This one, edge, select this edge. This one. Okay. Offset, later on I will take blind. That's it is up to selection. Up to selection. Selection, I am taking this surface up to this face. Okay. Now I am, for the internal hole, I am taking metric tab. M10 into 1.5. If the size in this chart your size is not available, you can override from here. You can write assign the value. Okay. But I have the size in the chart. Okay. And I cut thread. Tap and cut thread. In the internal threads, tap and cut threads. M10 into 1.5 mm and right hand threads. Okay. But initially, in order to get the proper threads from in start position, I am giving the offset of 1.50. Offset must you can give up to the pitch size, that is 1.50. Okay, but you are saying this is going thread inside, but I am reversing the direction from outside. Okay, this is the thread. If you see in the section, this one, you can see this thread is internal. Okay. Now save it. Second part, dot hex nut, that is B, hex nut B. I am assigning the hex nut A and hex nut B. This one, save it. Rebuild and save. Now we will make a assembly for this. While make assembly from the part, this one, or you can make from here also. New assembly, this one. This one, sorry, cancel. Insert component, browse, hex bolt. This one. If you want to rotate it, you can rotate about x-axis, y-axis. In this way you can. Suppose you want to rotate at y-axis, you can rotate it this way. This. I am taking this position. Isometric position, this one, or normal. This is the normal position of the bolt. Now, inside component, I am taking the hex nut. This one. I will rotate. How? As per requirement, this is along y-axis. I will rotate it. X, Y. This one. Now it is suiting. Okay. This is rotating of this one. This one. Now here in the view adapt tool, there is a axis, temporary axis. I am clicking this one, this axis coming. So mat, in the mat, this, select this axis. This is the bolt axis. This is the axis hex bolt. Now another axis, this nut axis, axis nut, coincident relation, this one, and cancel it. This one you can move the board this one. This way. Now it is freely moving in this direction. Now we will make a relation here. Here we will make a relation. First, hide the temporary axis, this one, and now Now first we will make a section, this one, for this is a bolt, and section this one, right plane of the bolt, and this is the section of this thing. Okay, now we will create a thread screw relation. For that, firstly you have to there should be thread should be adjusted in that way, in such a way of nut and bolt that there should be no interference between the threads. I think this is okay position. This is okay. And now this one, axis, mat, mechanical mat, screw mat. This is the distance per revolution. Distance per revolution means that is equal to 1.5 pitch. It will move in according to as per pitch. In 1.5, it will give one revolution in 1.5 at a distance. One revolution it move as per pitch 1.50. One rotation it will move 1.50 in the longitudinal direction. 0.50, 1.50. This one I am taking. Okay. Now this one, show temporary this axis, this one. So select this axis, or you can select the face. You can select the face of this bolt, this one, and second you can select this circular edge, this one. And now again you give the for the nut, give the pitch 1.50, this one, and reverse direction, that is automatically taking. Okay, now this, hit the right button and cancel it, and hide this axis, temporary axis. Okay, now this you move, this one, press left hand mouse button and hold and rotate it. Now it is rotating. This one, in this way it will rotate. This one rotated. Now we will make another relation, mat, clear. This one, advanced mat, distance mat. Select this minimum distance. I have here is given 50 mm. This is the 10 mm distance. 10 mm. This total length is the 60 mm. So minimum distance is 10 mm. This from S2 up to this thing. This is 10 mm. So minimum distance is 10 mm, and thread length is equal to 60 mm. Total length is 60 mm. So it will not go beyond the 60 mm nut. Select the surfaces, faces, this one and this one. I am applying the distance mat in this way. It will not move beyond the 10 mm. Okay, and hit right button and cancel it. Suppose. Okay, suppose you rotate this one. You can rotate this one. Press left mouse button, hold and rotate it in this way. We will give a simple animation how. Right click, toolbars, and this is the motion manager. This is motion study, and firstly you decide the time. Suppose I am taking, this is suppose I am taking 20 mm. It will complete. Okay. Now there is a motion study property. You select the frame 50 mm suppose, and this is the motor direction. This I am motor direction. I am direction, rotatory motor. This one component, this is fixed actually. Bolt is our fix. This is the first part in the assembly. I am selecting this dimension. Okay, edge. rotation RPM is equal to, I am taking 50 RPM. Okay, and hit right button, this one, and first calculate this one in this way, calculating. You can give, but it you can give 24 mm also, this one, and this again calculate. It will not move beyond this one because total length is 60 mm. 10 mm I have left without threads, so it will not move, or it will not move beyond 50 mm because 10 mm is without thread. In this way you can this is play button. In this way you can apply the, in this exercise we have created nut and bolt with thread feature and also applied the animation also. I hope you would have enjoyed in my this exercise. You please like, share and subscribe my this channel. Thank you very much. Thank you.